All right. So this is kind of like the last rule of differentiation that we're going to learn for a while. And it's called implicit differentiation. Now, you probably all know what the word implicit means by itself outside of a math context, right? Anyone want to help me out? The root there is implied, right? Implied. So if something is implied, it's not overtly stated, right? It's kind of like uh, subcontext, right? You gotta like read between the lines. Like remember back in middle school, you would go to somebody like, read between the lines, bro, and you'd hold your hand up like this or something, right? And that was just kind of, oh yeah, so anyway, um, the antonym of implicit would be what? Explicit, right? And then explicit, y'all are familiar with because all that music you listen to, like Metallica. Sometimes on their albums, they have a sticker that says warning, explicit lyrics. And what does that mean? Usually bad words. Now, here's the thing explicit does not mean bad. Y'all know that, right? Explicit just means that it is indubitably, without a doubt, clearly understandable what the message is that these people are trying to put forth, right? And when you use a curse word, that kind of helps give a little oomph to your message, right? And so that's why they say explicit. And then implicit would be, kind of like someone who's passive aggressive, all right? So what we've been doing so far this year has been explicit differentiation because we've been solving equations that have, get this, been explicitly solved for y in terms of x. Y equals, and then no y's on the other side, okay? But there is an implicit form in an equation, all right? And that's what we're going to learn how to differentiate today. How to take the derivative of a function that is not solved for y explicitly as a function of x, or one that actually is that way because it can't be solved explicitly for y as a function of x. All right? So let's go ahead and do the warm up together real quick. I know some of y'all have done it, and that's fine. This is just a review of the chain rule, right? We had the quiz yesterday. First step is to, rewrite it so that you can see layers, right? This is one term, right? One term. When you read it to yourself, 3 times cosecant squared of 5 times x. So if we're going to rewrite it, y equals, we got 3 blobs squared, right? That's the outer layer. The purple layer is the outer layer. Then you go inside and you're like, what's up, cosecant of blob? And then in the innermost layer, the innermost sanctum, if you will, you have the blobbiest of all blobs, the holiest of all holies, 5x. How many layers have we then? 3, right? Through 3 layers, when we differentiate, we're going to have how many factors? How many links in our chain? 3. That's the way you can take account of it for it. So here we go. What's the derivative of the left side? No, the other left side. dy dx. Very good. Very good. It's very important, right? This is an equation that is explicitly solved for y as a function of x. We have y equals, and there's no y's over there. So when you're taking the derivative explicitly, which is what this is called, you could just go straight from y to y prime or straight from y to dy dx. I did mention earlier in the year, though, that if you wanted to, remember the goal is to communicate, you could put the verb with a colon out in front, right? We've done that. D dx, the verb, colon. What does that mean? What does that signal? It means we are fixing to, in Texas, we're fixing to take the derivative, right? And then after the colon is the derivative. So you don't have to do this because when you go from dy to dx, the process is communicated. All right, so now let's go ahead and just finish this one. 3 times 2, that's 6 blob to the first. I don't need the 1, but I'm putting it, right? Accounting. And then I rewrite the blob. There's the next link in the chain, and we'll call it the Bendelay bullet. Okay, like a really beefy multiplication. The Bendelay, no Bendelay, not that one. And then dot parentheses, right? Not dot without a parentheses, because the derivative of cosecant starts with what? A negative. Anything with a co is negative. Okay. And what is the derivative of cosecant? Negative cosecant of x cotangent of x. Now, if it's not x, it's the blob. So cosecant of blob's derivative is negative cosecant blob, cotangent blob, right? The blob's in there. And then we close that parentheses for that link in the chain, and then times we put the bend delay bullet. And then we go to the innermost layer, which is in red. And then the derivative of 5x is 5, right? Do we put another 5 there? Because look, we have two 5x's. Do we put another one? No, because we're not taking the derivative of what we create. We're taking the derivative of this original function, okay? That 5x is there once, and so there it is. All right, now to clean this up, of course, you can pull the negative and the 5 and the 6 all out front and call it negative 30 cosecant what? Squared. Now you can do that because they have the same angle, 5x. So cosecant squared times cotangent of 5x. I'm not going to write that. Or yes, I guess I will. I guess I will. I was going to say I don't have time, but you know what? We have all the time in the world, right? Until the meteor hits. And then millions of years from now, people are forming a club, or the BC Calculus Club, right? All right, negative 30 cosecant squared. We can write it back in that condensed form, yes? Yes. Of 5x times cotangent of 5x. We don't need the bend delay bullets there because multiplication is implied, right? You can add them in if you want to. That's right. Now they're bend delay bullet points, not bend delay bullets. But points doesn't start with B. Unless we call it the bend delay bullet points. Bing bong also. How about the bing bong bend delay point bullets? The bing bong bend delay bullets, right? You know what? I'm gonna bring my kids' B book to school one day, and during advisory when we're all together, I'm gonna read you the B book. That's my favorite Dr. Seuss book. Oh, thank you, Mac. I was coming to meet you over there, but you dodged me. She is not here today. Yeah, unless she's still hanging out at the dinosaur club. Yeah, I think I have more than. Okay. So here's thank you, Mac. It's always good to see you. Hi, Mac. I'll take one, Mac. Speaking of bullet points, here are two reminders before we start. The derivative with respect to x of y, the verb of y is dy dx, the noun, right? It's essentially putting the y in the top. So the derivative of y with respect to x is just dy dx. Good. So what would be the derivative of x with respect to x? Well, we know it's 1, right? But here's why. If you do the same little trick, put the x in the top, you get dx divided by dx. And of course, anything divided by itself is 1. Yeah, so that's important, okay? I'll show you why it's important as we move on. All right, so we've seen an equation. Well, that's all we've seen. We've seen equations in explicit form. They're explicitly solved for y in terms of x. Here's another example, right? Y equals 2 over x, right? If we were to package this up and sell it to kids, we would have to put the label on the front. Warning, explicit math involved, right? And then the parents would forbid it, and then the kids would like sneak off and do these problems behind their parents' back, like in Panther Canyon, right? Or something. Yeah. I mean, good things happen in Panther Canyon too, right? Like Mr. Ortiz's survey. We should start a Panther club because you know what? There are no more Panthers in Panther Canyon. They're all extinct. We should capture some and put them back in. There you go. Now, look at this. Yeah, I mean, yeah, well, there's a subtle difference between a cougar and a puma and a panther, but we'll study that some other day. If you mathematically multiply this explicit equation on both sides by x, which is legal, okay? Let me tell you a little bit about doing that. If you multiply both sides by x, in general, it's not good to lose a variable from an equation, is it? Not good. Not good at all. But although we lose it on the right-hand side, guess what? It reappears on the left-hand side. So that's okay. What you don't want to do is if it's like x cubed minus x squared equals 0, and then you divide both sides by x squared. That would be bad, right? Because now it's gone, right? So don't do that. But it reappears on the other side, and we end up with xy equals 2. It still has the same genetic makeup, right? It's still the same genotype as the other equation. It just has a different phenotype, right? It looks differently. So xy equals 2. Now, if I asked you to take the derivative of xy equals 2, I would hope your first step would be to divide both sides by x and take the derivative explicitly like we've been doing, okay? But sometimes you're unable to do that, okay? Sometimes you're unable to do that. So what we're going to do is we're going to take the derivative explicitly like we're used to and implicitly, and we should get the same answer, right? If it's another method that's viable, we should get the same answer on both of them. And if we don't, then guess what? It's just going to be Dinosaur Club every day during fourth period because it's obviously not worth studying this junk, right? Yeah. All right. Fingers crossed, right? We're hoping, right? We're hoping, Ethan, that what? That it works or doesn't? Okay, good. Thank you. The dinosaurs, too, are hoping that it works because they were actually much more advanced calculus-wise than we were, but we lost all the information when the meteor hit, just like we lost a lot of information when the fire at Alexandria Library happened. We would be so much more advanced today if we had all the dinosaur technologies that they had at their time, right? We had to essentially reinvent calculus. There is a Leibniz and a Newton in the dinosaur world, okay? Find the derivative with respect to x. Okay, so here it is, y equals 2 over x. What's our first step here? Hody hi? No, bring the x to the top, right? 2 times x to the negative first. Okay, that looks good. Now, here's what I'm going to do. I'm going to show it, although it's not required. I'm going to put d dx colon. The verb, not the noun. That means I am fixing to take the derivative of both sides with respect to x. Okay? And so this is the step that also works. You could also do this, d dx of y and d dx of 2x to the negative first. Okay? Those both do the same thing. You either put d dx in front on both sides, or you put a d dx up front with a colon, okay? Those signify the same thing, but we don't need either of those in this case because it's explicitly solved for y. So we could go straight from this line to this line, dy dx equals negative 2x to the negative second, okay? Now having the line above is not illegal. You can totally have it there. It's not wrong. It's correct, okay? So having it there is fine, but it's not needed. Now we clean this up and we get dy dx is negative 2 over x squared. Boom. So again, notice that our original function 2 over x is it's undefined at 0. And if it's undefined at 0, so should the slopes, right? Look at the derivative equation. Is it undefined at 0? It is, right? Let's look at the graph of 2 over x real quickly here, okay? 2 over x is your parent function 1 over x, except it's vertically stretched by a factor of 2. So remember, it has a horizontal asymptote. What is the limit as x goes to infinity of 2 over x? What are the y values tending towards? They're going to 0, right? The y values are going to 0. What's happening to the slopes, though, as the graph goes to 0? What's happening to the tangent lines as we do that? They're getting less steep. They're starting to flatten out. They're approaching a tangent line that looks what? Horizontal, right? And what's the slope of a horizontal line? 0. Well, guess what the limit is as x goes to infinity of dy dx? Also 0. Wow. So it's kind of cool that the equation that gives us the y values and the equation that gives us the slope values, they're communicating through the ether, right? They just know how the other one is supposed to behave. Pretty cool. All right, now let's do that over here. Xy equals 2. I'm going to rewrite it. If you have an equation that is not currently solved for y explicitly as a function of x, your first step should be, can I solve it for y as a function of x? Because if you can, it's going to make life easier. But who wants an easy life, right? So I'm not going to do that here because I'm trying to prove a point. Now, here's the deal. When you take the derivative of something that is implicitly solved for y as a function of x, you have to signify what you're doing on the next line. And so the easiest way to do that is just to put d dx the verb, rather than put d dx in front of both expressions on either side. That's just a little bit more writing. Okay. So you do that. That tells people, hey, I'm fixing to take the derivative. Now, if I do that, what rule am I going to be using out of the box over here on the left if I have two variable functions multiplied together? The product rule, right? And so with the product rule and two factors, we're going to have how many terms when we're done? Two, right? And we do one at a time, one at a time. So here we go. What's the derivative of x with respect to x? It's one, right? Now, I'm going to just write it as the derivative of x with respect to x, if you would allow me to do that. We know it's one. The derivative of x with respect to x is dx dx times y goes along for the ride plus x goes along for the ride times what's the derivative of y with respect to x? dy dx. Yep. Equals, and then what's the derivative of a constant with respect to x? 0. I ain't changing, right? So that's the product rule. Now, here's why it's important that you denote which variable you're differentiating with respect to, because you're going to have more than one variable. And in the denominator, I can see x then is my independent variable. All right, independent variable. Now let's simplify. Dx divided by dx is really 1. So now I can drop the parentheses because they were there just for helping me find the derivative. Now, is that it? Are we done? No. And here's the thing that you're going to notice when we take the derivative of a function that is not explicitly solved for y as a function of x. This process that we just did, this is called implicit differentiation. Implicit differentiation doesn't mean that you're not sure of yourself when you take the derivative. I misspelled differentiation. Wow. Differentiation. There you go. When you take the derivative implicitly, you're not shy about it. You're not unsure about it. You're not tacitly saying what the derivative is. You're finding the actual derivative. You're just doing it on an equation that's not solved for y. So guess what the next step is always going to be? Yeah, we're trying to find the derivative of y with respect to x. So you're always going to have this algebraic step at the end. You're going to have to solve for dy dx. Yay, algebra, right? The calculus is over, by the way, right? Calculus is over. It's always going to be just one line and then he leaves, right? And then we're left to clean up. So let's go ahead and solve this for dy dx. Let's see, I'll use, let's see, dark green. I like dark green. So I get x dy dx. Red rover, let y come on over. And now it's negative y. And now I got to do is solve. I'm going to do a new column over here. I'll divide both sides by x, and I get the derivative of y with respect to x is negative y divided by x. And then compare it to what we got above, negative y over x and negative 2 over x squared. And you can clearly see that they are exactly the not same. Dinosaurs it is. Okay. Yeah. Maybe there's still hope, right? Because what do you notice about our implicit derivative? It has what in it? It has a y in it. Okay. Now, most of the time, when you take the derivative implicitly, you're going to have y's in your derivative. And it's because you probably couldn't solve for y explicitly in the beginning. Okay. Now, let's see why implicit differentiation is needed. Up to now, we've been looking at curves that are functions of x, right? They pass the vertical line test. But we have other curves that don't pass the vertical line test that are curves as well, right? And they want some love and affection. They want some love and affection. That's my dinosaur. Yeah, I don't know what the equation for this curve is, but what if I'm trying to find the slope of the tangent line right here at this value of x? Okay, would I be able to know which one I'm looking at? No, because if you notice at this specific value of x, there's how many y values? 3. So in order to pinpoint exactly where I want the slope of the tangent line, I would need not just the x value, but I would need the y value. I'll use K. Okay. I need the ordered pair. I need the point. And that's why implicitly you'll very often have X's and Y's in your answer. You need an ordered pair because you can't solve for Y in the beginning. Okay. So anyway, there you go. Maybe that could be the new logo for the Dinosaur Club. Nah. The one he has is cute. I like it. Yeah. Yeah. Did you draw it for the club?
Me?
Yeah.
No,
No?
I just doodled this.
Oh man, you're a good dinosaur doodler. Yeah. So here's what we're gonna do. I could have solved this original equation for Y, but I chose not to, right? Because I wanted to show off my implicit differentiation skills, or I was too lazy or whatever. But guess what? If I want to put this back in terms of X exclusively, I can then return to my original equation, solve it explicitly for Y. Well, I already know what Y is equal to, yes? Y is equal to what? 2 over X. 2 over X. Let us substitute that in, shall we? So we get the derivative of Y with respect to X is now negative 2 over X all over X. Be careful where you put your main division bar. If I simplify that, I can do lick 'em over lick 'em, or I can do state change flip, but either on the clock. Oh man.
Good afternoon. Pardon this interruption. This is a reminder that picture retakes are today, and they are in the lower commons. The photographer is only going to be here a little bit longer, so if you have not taken your retakes, you need to come do that now. So picture retakes in the lower commons, please come get it taken care of. Thank you.
That was an argument too when they found the first brontosaurus, which we now know is a brachiosaurus. There was an argument among the paleontologists, what the total length of the dinosaur was. And one of them actually said exactly what she said. She says, it's going to be just a little bit longer. And so they're like, okay, all right. How's Alec Baldwin doing?
He just showed up in Vermont.
Yeah, I heard that he's not really culpable as the actor in the shooting, but as the executive producer of the movie, he's going to be liable.
Yes, sir.
Yeah. So anyway, we finished this example. We're going to boogie when you get back. So get some nourishment inside of you. Okay.